Today we're going to talk about kites. It's a quadrilateral section, and we're going to begin talking about kites on these, and we'll talk about several quadrilaterals. And a quadrilateral, of course, is a four-sided figure, four sides, four angles. And we're going to jump straight into kites. We'll eventually talk about squares and and rectangles and the ones that are more familiar. But for right now, we're going to jump into kites. These notes have been posted to you. If you haven't found them on Canvas, go ahead and look now. But we'll take through these notes and then I'll allow you to do some practices on your own. So the first thing we're going to look at is the properties of a kite. Now, when we jump into the kites here, we want to first notice that all quadrilaterals have 360 degrees of interior angles. Just like we talked about with a triangle having 180, the quadrilaterals have 360. And three sides, 180. Four sides, 360. Anytime you add a side, like a pentagon, is going to have 540 degrees. So it's important to remember that all quadrilaterals, as we go through this, have interior angles of, sum of interior angles of 360 degrees. All right? And a kite, what is different about a kite is it's a quadrilateral that has exactly two distinct pairs of adjacent congruent sides. That's a fancy way of saying this. We have two equal sides that are touching one another. So on our kite that we can see here, we can clearly see our markings. This side and adjacent means next to or touching. This side is equal to this side, and this side is equal to this side. So that's the first thing that we need to establish when talking about a kite. Really, that's all it takes to have a kite. Here are some important facts we need to know about a kite. The diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. So the diagonals connect opposite angles. So as we're looking at this, we can see a diagonal. This is not labeled, but if we were to label this kite, it would be kite A, B, C, D, because it has four parts. But AC forms a diagonal and DB forms a diagonal. When the two diagonals of a kite intersect, they form a perpendicular angle. And again, remember that means equal to 90 degrees. One pair of opposite angles are congruent. A lot of times this is very clear to see, which is the ones that are congruent, kind of like the figure that we are looking at. We can clearly see that this angle on, if we're talking about the north end, is definitely larger than the south end figure. And then we can see that the east and west, so to speak, are potentially the same. But we can also take a look and see that we have essentially two isosceles triangles laying on top of one another. One isosceles triangle there, and one isosceles triangle here. The thing to remember about isosceles triangles is, yes, they have equal sides, but they also have equal opposite angles. So if this angle is equal to this angle, and then on the other figure, this angle is equal to that, clearly if they have two equal angles forming that one side, then they're equal to one another. So the second little fact we have, one pair of opposite angles are congruent. In this case, if I put my letters back, what we're saying is angle ABC is congruent to angle ADC. And remember, we cannot name this B and D because B and D both could refer to two different angles, so we can't name it that. So the next little fact that we see is the other two angles are bisected by the diagonal. So we just established that the east-west portions of this kite are equal in angle measurement, which means the other two angles, that would be the angle which is kind of our north pole, and our angle that is the south pole here, which is C in this particular one, then remember they're not equal, but they have both been cut in half. So the resulting angle measurements here, here is equal to here, and here is equal to there. We're going to double mark those two things because we have two congruent angles, but they're not congruent to each other. And then the last little fact that we see on our little sheet here is what has already been mentioned. We have pairs of congruent triangles. We have the triangle on the top. We have the triangle on the bottom. That's one we spoke about. But let's talk a little bit further on this. When we cut this angle in half in the top, we've actually created, a congruent triangle here and there. So those are also congruent triangles. And of course, we're going to have the same thing on the bottom. This triangle here is going to be congruent to this triangle here. Just like that. So that's what we need to keep in mind when we're looking at kites, is that we're going to have a lot of isosceles triangles. Let's take a look at some examples. All right, so first example we have here, we see that we have a kite. The reason why we have a kite, one, they tell us it's a kite, but two, they don't need to tell us this because they have marked these as congruent adjacent sides and then a second set of congruent adjacent sides. And then the thing they're asking us for here is the measure of angle T. Now we can call this angle T because T is only the vertex of one angle. So we're looking for this angle measurement over here on T. So let's talk about what's important about T. Well, one thing we hopefully should recognize is that T is going to be, the measure of angle T is going to be equal to the measure of angle R. Because they're clearly the two that are equal. We're always going to have equal sets, and the 46 is clearly not equal to the 78, so we don't have a match there. And we know that T is equal to R because we learned that about kites. Think about the other information we know about kites, and not just kites, but also any quadrilateral. Hopefully what comes to mind is that the sum of interior angles is 360 degrees. So all the four angles added up are going to add up to be 360 degrees. So let's think about what our four angles are. Angle U plus angle S plus angle T plus angle R should equal 360 degrees. Well, let's substitute what we know. We know that U is 46 degrees. We know that S is 78 degrees. We know T is the one that we're looking for. And here's where we're going to use that substitution method. We also know that T is equal to R, so why not substitute R with the angle T? So this combines to equal 360 degrees. So we are going to subtract away 46 and 78 to the other side. Put that in our calculator. When we subtract both of those numbers away, what we end up with is 236 degrees. We have 236 degrees, and then we have angle T twice. So we're going to go ahead and drop the angle measurement and just put 2T. But we have 2T angle measurements that are combining to equal 236 degrees, remembering that this angle is equal to this one. So what we do lastly, a little bit of algebra here, we're going to divide both sides by 2. And then we have the angle measurement for angle T. (118 degrees). Now, as always, in geometry, always pay attention that you answered the question that was asked, and the question was, what is the measure of angle T? So angle T has an angle measurement of 118 degrees. So here we are again on another one, and we're given the two angles opposite of one another that are clearly not the congruent angles. And then we're going to find what the angle measurement of angle D is. So that would be this angle right here. This one is just like the last one, we just have different values. Remembering that our kite is 360 degrees. What we can do as well is we can subtract. You don't have to necessarily set up an equation. I suggest that you do, but we can just simply come in here and subtract these numbers away, excuse me, and work this out. Mental math as well. Nothing wrong with setting up a formula, but we can do it this way. So of our 360 degrees, after we take 115, there's 245 degrees left. Then we'll take away the 61 degrees from the angle E, and we will have, sorry, click my pen here, 184 degrees. So there's 184 degrees left in our quadrilateral, this kite in this case, and both of those angles are equal to each other. It would be angle F plus angle D would equal 180 degrees, and we're going to use that substitution method because we know that F is going to be congruent to D. What we really have is angle D plus angle D. So basically we have two angle D's equaling 184 degrees. Just like the last time, we'll divide by 2. And we get 92 degrees. Good way to check this one as well is to just add your four numbers up and see if they equal 360 degrees. So it would be 92 plus 92 plus 61 plus 115. Those numbers should add up to be 360 degrees, but that's another way of checking. All right, so now we've got some more interesting things. We're going to throw into the equation our diagonals. So all the stuff we said is true about a kite. We can go through and label all these things. Don't know if we'll need everything or not, but we know this. This angle measurement is 90 degrees, or excuse me, 90. This is equal to this. And don't be confused. Don't be confused with the fact that our kites the sides don't add up to 360 degrees. Only those interior angles do. It's also important to keep your facts about your quadrilateral close to you so you're able to use these. So what we're looking for in this case is the measure of angle VZ. Well, that would be from here to here. So we're looking for this angle just like that. Anytime you're looking for these, and if you're when we do proofs, what you want to think about is what is that to a different shape. Okay, it's obviously half of a diagonal for our kite, but what else is it? And if you look closely, what you see is that it is the bottom leg of a triangle. And I'm highlighting this triangle in green here, so it is the bottom leg of this triangle right here. And I'm just calling it a triangle, but more specifically, if we look back at our facts, we should think about this. What kind of a triangle is this? Be careful not to say isosceles, because this one is not isosceles. That bigger one is. But what we have, remember, anytime those cross one another, they form a right angle. There on the inside. So what we have is a right triangle. And anytime we have a right triangle, we get to use our old friend, the Pythagorean theorem. Leg squared plus leg squared equals the hypotenuse squared. Now what we need to do is identify what we have. And really all that matters is, do we have the hypotenuse? And yes, we do. It's 90 degrees. Or I said degrees, 90 unit measurements. One of our legs is 54, and our other leg is unknown. That is what VZ will be. Put a nice little X here to remind us. That's what we're looking for. All right, so we'll go through Pythagorean's theorem. 90 squared, 8100. 54 squared is 2,916. We're going to move the 2,916 over to join the 8,100. Gives us 5,184. So we need to now take the square root of 5,184. Which is 72. Now keep in mind all those little facts that we've talked about triangles. Remember, the two smaller ones have to add up to be larger than the largest one, but they can't be larger than the hypotenuse. So 72 fits that category because it is smaller than our hypotenuse, check. And 72 plus 54 is bigger than 90. So this can be a triangle. Always check that. It's a real quick look, and you'll know. I mean, you'll know if your answer is wrong. All right, here's another problem. It's just in different information, and we're looking for a different thing. So let's go ahead and do that. GI is a measure from here to here. And we are looking at the triangle. What else is this? Well, it's a part of the triangle HGI as well, but that's not very helpful because we don't know any of those parts. Yes, it is the bottom of that, but we want to choose something that we clearly can see. So GI, here it is the bottom of another triangle, and more specifically, a right triangle. So we have a right triangle here, and again, we have the similar aspects here. We are going to use Pythagorean's theorem. And keep in mind the parts that you have. We have the hypotenuse of 68. We have a leg of 60. And we have a unknown leg, which is GI, which is what we're looking for. All right. So I'm squaring 68 right now. When you square 68, you get 4,624. When you square 60, we get 3,600. We're going to subtract the 3,600 over to the other side. So this leg squared is equal to 1,024. And the square root of that number. And another little red flag, if you ever get a negative number there, you got a problem. One, you can't take the square root of a negative number. And secondly, the hypotenuse squared should always be bigger. So you should be subtracting a smaller number from a bigger number. So it should always be positive. Square root of 1,024 is 32. So what we learn is this side is 32. Let's make sure we answer the question that was asked. GI is 32. That is correct. But look, I mean, think about the other things they could ask us. They could ask us what KI is. They could ask us what KI is. Well, KI, we do know. Because if GI is 32, GK is also 32. Remember we said that one bisected. That diagonal bisected the other one. So KI would have a measure of 64. So make sure you read the question, because you may not even have any parts to that, but you'll know this based on our kite rules. All right, taking a look at this one. This one is a little bit misleading. It's kind of hard to tell exactly what this 8x is referring to, but I'm just telling you the 8x is referring to this angle over here. So here's where we're finally going to use our isosceles rules. So clearly 5x refers to this angle, this one. Not so clearly, but it refers to that one. They're part of two different triangles. The 8x is part of a triangle on this left side, and the 5x is part of a triangle right here. But the things we've got to keep in mind are the other rules that go with a kite. The other rules being, remember, this diagonal cuts this angle in half, and it cuts this angle in half. Well, if it cuts that angle in half, that means this side is also 5x minus 1. So now we would have two parts to that triangle. Think about that. Actually, we'd have 3. This would be 8x. This would be 5x minus 1. And then the one thing we should have highlighted right off the bat is that these are perpendicular. So those are 90-degree angles right there. So we have 90-degree angles. What we also could have done, and what I'm going to go with is on this one is, well, remember, if this side is equal to this side, their opposite angles are equal to each other. So if that's 8x, that is also 8x. So I've got my triangle drawn up here. We'll just go with this one. So the sum of interior angles of a triangle, remember, are 180 degrees. Well, 90 of them are in the 90-degree angle, so there's 90 gone. So the remaining two angles combine to equal 90 degrees. Remember the word for that, complementary, right? So here we go. Angle 1, 8x, plus angle 2, 5x minus 1. Technically, we should have some parentheses around this thing, but being that there's a plus sign in front, they're unnecessary. So these two terms are on the same side, so don't do anything tricky, just put them together. 13x equals 90. 13x minus 1 equals 90. We'll then move our 1 to the other side. Addition rule of equalities, by the way. So plus 1, not a minus 1. Sorry about that. So we have 13x equal to 91. So lastly, we are going to divide by 13. And then we learn that x is equal to 7. Double check, make sure you answered the question that was asked, because the question could have asked what an angle was, or it can ask what x is. You've got to be on guard. And this one does just simply say solve for x, so our answer is the correct answer. You could plug these values in, make sure that these all equaled what they're supposed to equal. They all should add up to 180 degrees because we are dealing with a triangle in this case. All right, this one's a lot of fun. So it says find the perimeter of the kite. Well, the perimeter is the distance around the outside. We don't have any of those values. We don't have any of those values. The good news is this is isosceles triangle. So once we solve two of these angles, we'll have all 4 of them. So let's highlight here one triangle that we have. We have an 8, 10, and then we're missing our hypotenuse. So we'll pull this over here and take a look at what we're looking at. Triangle that has an angle measurement or side measurements of 8 and 10. And we're missing the other side. So let's do Pythagorean's theorem here. Leg squared plus leg squared equals the hypotenuse squared. I labeled it x, but that's okay. Hopefully we can make that a mental adjustment as we go. 8 squared is 64. 10 squared is 100. Together they make 164. So now we're going to take the square root of 164, and then we'll have our measure there. So this ends up being 12.8. This side measurement is going to be 12.8. Which means this side is also 12.8. Now our second triangle we're going to take a look at is the one on the bottom. We'll do this one in red. It is also missing its hypotenuse. But the sides that we do know have a side measurement of 15 and 10. This is a right triangle. This one was too. So we are going to go leg squared plus leg squared to give us our hypotenuse squared. Those are a couple of powers that I'm used to, so I'm going to just go ahead and do those. Together they make 325. And the square root of 325 is, it's not 18, but it wouldn't round up, so we're going to call it, and we're going to actually put approximately 18. I should have put approximately on the 12.8 as well, because anytime you round, you have to denote that you have an approximation sign. So this is approximately 18. It's actually 18.027, so it'd be 18.03. So what that means is this side has a measurement of 18, and so does this one. If you wanted to keep these in the most accurate form, you would have left them in their square root of 325 plus the square root of 325 plus the square root of 164. We don't need to do all that. But in this case, we are finding the perimeter. So, and remember, the perimeter of a number is simply to add up all of its sides. In this case, we have 4 sides. So we would add up our 4 sides. 12.8 times 2, essentially, because we have the same thing. We could do that. Plus 2 18s. And when we do that, what we get is 61.6. And this is an approximation sign because we were working with rounded numbers. Remember, when you work with rounded numbers, you have to make note of that. All right, our last example. Say the best for last here. I like the angle measurements. They're a little easier and faster to work through, but don't be in a rush. So here's what we want to do first of all. One of the most commonly overlooked things is the easiest thing. This is 90 degrees. This is 90 degrees, which means this is 90 degrees, which means this is 90, which means this is 90. All right, remember the rules. Not all of the angles get cut in half, just these top and bottom ones. So whatever this angle is here, Y, this one is the same amount. So once we have one, we have the other. So here's what we have. We have really 2 types of triangles. We've got this triangle right here, and then we have a one just like it. And then we have a triangle in the bottom, the green one here. And then we have the one on the other side that looks just like it. We actually have 2 of our 3 angles. Remember, the 90 degrees is one of the 2 angles. So what we're going to do is set up our equation. Some of this you can do with mental math, but the 34 degrees plus the 90 degrees plus that angle, let's call this one X, should equal 180 degrees. So we would take the 2 angle measurements and subtract them from 180. When we do that, we get 56. We subtract 34 and we subtract 90. And if you're wondering, well, couldn't you just subtract the 90 and call it 90? Yes, that would be a great move. So what we learn is our angle measurement that is missing is 56. So this is 56. And notice it says find all the missing angles. I guess they're technically not missing. We just don't know what they are, right? So this one is 56 degrees, which means this one is 56 degrees. And remember, these are not cut in half. And by the way, this one is 51 degrees because that one is 51 degrees. So in the bottom there, we have the green right triangle. We know there's 180 degrees. 90 of them belong at the 90-degree angle. So the other two angles combine to equal 90 degrees, the 51 plus the angle which I called Y. So what we do is we subtract our 51 away from our 90. And we learn that our angle Y is 39 degrees. So if this is 39 degrees, so is this one. And now we have established all of our missing angles. All right, you guys have your practice that you're looking at. You guys go ahead and get to work on that. Good luck.